Hello and welcome here in our workshop at Ottobock. Today's topic will be lamination resins versus reinforcement materials. On my right side, I have my colleague Tino Hartmann, who is a CPO.
Hello.
And on my left side, I have Dricus Reinicke. He is also a CPO. Thank you very much for joining us, and I will hand over to my colleague Tino.
Thanks, Heinrich. Let us start with the different resin systems. In our safety cabinet, we have all the liquid resin systems that are available at Ottobock. The first group of the resin systems...
Different ones, huh? Because we see different colors and different... Okay.
Exactly. Okay. We have three different resin groups. The first one are the acrylic resins. There we have a lot of different resin types. Let me start with the first one and explain step by step. The sealing resin, it's well known since many years for gluing and isolating surfaces and glue wood and foam, for example, together. The soft resin, soft and extra soft for flexible parts in prostheses or sources or flaps, for example. Then we have the 80-20 speed, fast reacting resin for small parts, small components that has to be done in 15 minutes, for example. 80-20, the classics since many years, well known in our field. Then the C-also acrylic resin, C stands for carbon fiber, so carbon-based reinforcement devices, and 80-20 Pro, the acrylic resin with the lowest viscosity, where you can combine carbon fiber with any other reinforcement materials. The second group are our epoxy resins, called Orthobock at Ottobock. And this we would like to show you in the practical part together with our colleague Dricus.
Okay.
But before we start with the lamination, we have to do the reinforcement.
Can I ask you quickly a question? You're talking about reinforcement materials. Is there any difference in reinforcement materials?
Yes, we have different reinforcement materials for the Ottobock resin family. You can use the standard reinforcement materials, all that you have in your workshop, plus these Ottobock reinforcements, and one of these is what you see here in white, is the Ottobock woven flex. Like Dyneema, if you know this material from Prepreg. So it's made for flexible areas, for example, at the TF socket, the gluteal area where you want to sit so that it's flexible, or for flaps like we are doing here in orthosis. That's one of the material. And the second one, what you will see afterwards, is the carbon fiber, but both of these materials has a special binding on the surface. So a higher amount of this binding that the resin gets in contact, so that it bonds to the fibers that we have here.
Is this material that we see right now?
Exactly, that's the Orthobock carbon fiber. So the advantage for the CPO, like Dricus is doing now, the reinforcement, is the high amount of this binding. So it makes it easy to cut. You see, there are no double tape, no around the edges when you cut it, so the fibers are not frying, they're not coming out. So it's much easier to apply these layers.
So he prepared it now for the next steps, is it right?
Exactly. So we prepared the next step after the reinforcement, what you can see behind Dricus, where he's hand over to the next one, exactly. So this is already prepared with the PVA bag, so the last layer, standard reinforcement, all that you need in your workshop, you can do, and this is prepared in that step. So before we laminate, we want to show you what's necessary when you mix the resin.
Is there anything I have to be aware of, or is there something special about this?
That's not the same way to mix the resin, so the A and B component, resin and hardener, like you know from the acrylic resins. There you can be flexible at the acrylic resins. 100% of the resin and 1, 2 or 3% of the hardener. So you can decide less or more. If I have a K-foam, I take less. If I have a TT socket, I take more of the resin, of the hardener. Here at the Ottobock resin, it's a fixed mixing ratio, because it's a poly addition called, and there we have 100 parts of the resin and 26 parts of the hardener. So you can't do 25 or 27. It should be exactly
Should be
this.
26.
Otherwise, some parts are not finally reacted and they are free in the reaction. So you should be aware of this mixing ratio.
When you combine the resin and the hardener together, do you have any specific time to mix it, or you have to be fast? Is there anything?
The process, when you weigh it on a scale and when you mix it, is the same for all the liquid resins. So at the same time, the 3-5 minutes, that's what you need for that process. When you laminate, there is a difference. Acrylic resins reacting in 45 minutes, 1 hour, and then they are done. Then they are made for cutting out and demolding.
Okay.
The epoxy resin should stay after the lamination process for further 10 hours under vacuum.
So after he put the resin into this vacuum bag, he should wait for 10 hours.
Exactly, and make sure that the vacuum pump is running for the next 10 hours. You know, in some workshops overnight there's a main switch, power is off, so you're coming back in the morning and then it's full of bubbles. So make sure it's running when you laminate in the afternoon or in the evening, that it stays for 10 hours under vacuum. That's important.
And the lamination itself, is it something different, or you can just...
Same process like all liquid resins. Pour the resin into the PVA bag and then mold it into the reinforcements materials.
So now, now we see Drico's getting ready for the lamination, is it right?
Exactly, yeah. So he filled the resin in the PVA bag and then he is closing the PVA bag and then, make sure that the resin is covering all the fibers. So a property of the epoxy resin is it has the highest strength. Better than all the other resins, better than acrylic resin and vinyl ester resin, what you'd like to show you later. And the strength of the resin, because it's so high, you need less of the reinforcement material. So the wall thickness of the device later is thinner, but the strength is much higher than with other lamination resins. And to get these strengths out of the epoxy resin, so to get this property, after the 10 hours under vacuum, you can cut out the device, remove it or demold it from your foam or your plaster cast.
So next step that we are looking at.
The next step is prepare 2.
Thank you.
So the final orthosis. Then you have to anneal the orthosis in the oven. So you have to temper it at special temperatures. I will explain what's the first step. So you put the orthosis in the oven. And the first hour is at 60 degrees.
1 hour.
1 hour, exactly.
What happens after the hour?
After this 1 hour, it's made that you can grind the edges to the final trim lines that you need, because it's much easier. Otherwise, it feels maybe a little bit like rubber during the grinding process. After that hour, when it's finally grinded, put it back in the oven for another 10 hours at 80 degrees Celsius. So all is Celsius, first 60 and then 80 degrees Celsius. And then after these further 10 hours, it gets the final strength. It's a special process you have to do with epoxy resins. It has the highest strength, but you have to follow exactly from the mixing until the final annealing in the oven to get all the good properties.
And then you're ready with the final product.
Then you're ready. So both I would suggest to do the lamination and the annealing or tempering in the oven in the evening or afternoon. When you're not in the workshop.
The strength and the weight of the product are the benefits for this.
Exactly. And this you can get just with epoxy resins. Thin-walled devices, less amount of layers, but a high strength.
What else do we have?
Come over, I will show you the next one. The next resin, the third group of resin. We had the acrylic resin, we had the epoxy resin, are the vinyl ester resins. And here is the benefit or the advantage of the resin. More or less the same mixing ratio like the acrylic resin. Here we had 100 parts of resin, 1, 2, 3 parts of the hardening powder. Here we have 100 parts of the resin and 1 or 2%. So you're still flexible. 1 for a big device, 2, and 2% for a small device that you have to laminate. But the time or the bonding to the fireways is more or less the same like the epoxy resin.
Okay.
It has the highest strength. This is close to it.
Okay.
But the lamination process and the final annealing is shorter than with the epoxy resin.
Okay.
So it's a good compromise for you.
Okay.
This we would like to show you, just that you see the difference, that you can use, Rikus will show you this now, that you can use the standard hardening powder in your workshop.
Okay.
So you don't have to buy the special epoxy resin plus the liquid hardener. Here you can use the hardening powder like you know from the acrylic resins.
Okay. And you can also speed up the process.
Exactly. When you take 2%, it's faster. When you take 1%, it's slower. With epoxy resin, no. That should be exactly the mixing ratio. But remember, I said you have to leave it 10 hours under vacuum, so you have a lot of time to laminate with the epoxy resin. So we cannot speed up, we cannot accelerate the process with epoxy resin. It's a chemical reaction, and it is like it is.
So when you make a mistake here in between of 1 and 2%, that's fine.
Exactly.
Okay, but
with
no
epoxy,
mistakes.
With epoxy resin, put it on a scale, weigh it exactly, and not 1 or 2% higher or lower. It does not work. It looks maybe okay, but it's not. The final reaction is not done.
So after mixing the hardener and the resin together, we have the same process.
Same lamination process like with the other two liquid resin systems. It's not prepared now, but you have seen it once, so there's no difference.
Thank you very much.
What we're doing. Good. So the vinyl ester resin. It's an efficient product because it has both properties, so you can say a compromise of the acrylic resin and the epoxy resins. So it's up to you what you're doing. Should it be fast? I have no time. Or I want a good product with a high strength, then I use epoxy and so on. At the end, I will give a key message or summarize all of that. So other good efficient products, we have two in the reinforcement materials.
Okay. Is it now that we are looking at?
Exactly. Yeah. So one of the products of the efficient reinforcement products you've seen all there at the lamination workbench, the carbon fiber from the roll, uni, bidirectional, and so on. All this is done in one product.
Okay.
So it's called.
Also the layers and.
The layers are all pre-tailored, so stitched all together, so that you don't have to cut 10, 12 layers and put layer on layer with double tape or spray glue in between. What's not good for the result. So you have just one layer. It's a cross inside with a hole in the middle, and you can use this called anchor preform, and the name said it, for the adapter, for the anchor, and it works with this hole here in the middle that you see also for shuttle locks. Okay. So you see, just stretch it over and then fix it with spray glue or double tape, and it's multi-directional layer inside, it's just one step, so it's efficient.
So we only have the reinforcement materials for the anchor, or do we have something?
We have two more
for other areas of the socket?
This is for the anchor. Okay. You can use it in any sockets where you have an adapter. And we have two extra ones in different sizes and in different shapes.
For above knee, yes?
For above knee, for TF, exactly. And one is for frame design and one is for a container socket. And this we have in different lengths, that it fits to the shape. So what you can see there, Dricos is showing what's in the box here, is one layer for the axial reinforcement, so from medial over distal to lateral. And at distal you see, it looks maybe a little bit like the anchor preform, so it has this cross shape there. All layers in one. Then the second is for the radial reinforcement. So you see it's a triangle and it has a double S shape, so it's pre-tailored. And you can drape it a little bit that it fits to any style of socket. So we are looking for all the designs of socket that we have around the world. You know, thousands of different designs, but you can drape it and still possible to put
all sizes as well, huh? Because it's big enough.
All sizes. We have, as I said, two different sizes. So you measure the plaster cast or the foam model, and then you decide the bigger or smaller one that fits for you. Then you have to laminate the socket. In this case, it's a frame socket. You go to your transfer jig. Transfer the position of the adapter. When this is glued on your laminated socket, we have another small cross in there. Looks like the anchor preform, but shorter arms. Here we have windows in the socket, so that the windows are not covered, but the same function. So all in this reinforcement kit. Sufficient, quick, one layer for axial, one layer for radial, so not 12 single layers with something in between like a double tape. And the edges are tapered, so we have a smooth transition from the reinforcement to the flexible socket inside.
And there is no waste of material.
Exactly, yeah.
Okay.
Yeah.
Okay. Really interesting. Thank you very much.
Goes fast and no waste. Exactly. That's the key message. Yeah.
What do we have else?
I want to give a summarize of the products.
I think we have something else.
Yeah. Right. We have from the liquid resins. As I said, we have the acrylic resin, we have the epoxy resin, and the vinyl ester resins. And in the family of the epoxy resins, we have some pre-reacted resins. The pre-preg. And here, the product what we are showing is the resin film. For those who don't know,
already reacted.
It's not final reacted.
Okay.
But the resin and the hardener is already mixed. Okay. So for those who don't know what is pre-preg, pre-preg, then we have the carbon fiber or aramid fiber, and inside is the epoxy resin with the hardener already applied, so rolled into the fibers. It has to be stored at minus 18 degrees, so the resin film too, because the reaction goes further and further. So to stop or to slow down a little bit the reaction, it's frozen at minus 18 degrees Celsius. So this is thawed before we started here to the room temperature. And now Dricus will remove the foil from one side. There we are using a file brush, where you can clean metal file or wood file.
It's a practical tip from your side.
Practical tip, exactly. This little metal brush, fibers are crawling into the foil, so it's easier to remove than with your fingers. It's sticky, the foil. So now you see the resin film from one side, and on the other side is a proof paper. This is not so easy to remove. So we are starting with the foil. Now he's using all standard reinforcement that you have in the workshop. So it's good when you want to start with pre-preg, you want to get some practice with the technique, you can start with resin film. Or if you're still using pre-preg and you have, for example, at orthotic joints, the bars, some air bubbles, because the amount of resin is not enough in pre-preg, you can use the resin film to give more resin in this area. So he's using a silicone roll now. Roll it on the carbon fiber. And to remove the proof paper, it's a little bit tricky. And here we're using eye spray.
Why eye spray?
So the resin film gets frozen again, and then it's easier to remove the proof paper.
So we were talking about waste of material in our reinforcement materials. This looks like we also have a benefit of the material that we use resin. Is it right? When you laminate, it depends on your experience, always a guess. 100, 200, 500 grams, what is good? And at the end you see 120 was enough, but 500 was steered. So here it's exactly the amount of resin that you need, because layer by layer you apply it. With pre-preg it's the same. And you can decide too, when you cut, like you see there, the resin film a little bit smaller than the reinforcement. So you can save also resin weight in the lamination. So, and you have the same amount of resin on your carbon fiber material? Yeah. So the relation of resin to fibers is in the best way here. So 80% you can say reinforcement materials, 20% resin. So after that, we prepare it also? Is it we prepare the next step, exactly. That's what you can see here. So when the reinforcement is done, you can cover the whole reinforcement with a peel ply to get a rough surface, or with another foil to get a shiny surface, up to you, what you want. Here it's already prepared, so the outer PVA bag is also done, and it stays under vacuum the whole time. Now we disconnect this from the vacuum pump. And we have to bake the resin to give the resin or the reaction an impulse that it goes faster. Is it the final reaction that we... Exactly. The reaction goes further and further because it's already mixed, the resin and the hardener. And we store it at minus 18 degrees Celsius, that it is a little bit slower, but it's still going on. And to make it faster for us, that it's done in, for example, 4 hours, we go to the oven, set it under vacuum there, and then
the lamination process will be done in the oven.
Okay.
So
Is
we
the time how fast you will finish based on the temperature we use, or?
The temperature is fixed. I will tell you what is the correct temperature.
Okay.
So what you need for this process is an oven with a vacuum connection inside.
Thank you.
So he closed the vacuum tubes there, that it stays from the lamination unit to the oven and the vacuum.
Okay.
Connect it in there and opens the tap again.
No rush, or you have to be aware over time?
It does not take more than 5 minutes. That's okay. Yeah.
But
so
you
when it's
can't
good,
undo it from the vacuum and then have a coffee and...
I suggest don't do it today and laminate it tomorrow. No, it should be on the same day. That's the best way. Yeah. Then it will stay on the vacuum for 5-10 minutes, and you don't lose the connection to the vacuum. Okay, so it's in the oven. Now we adjust the oven to 90 degrees, or it should be already adjusted to 90 degrees Celsius.
And then finished.
No, it's not finished. After 15 minutes, we take the silicone roll again.
Okay.
So we say now 15 minutes are gone. The resin gets liquid inside.
Okay.
So it's penetrating its distribution to the reinforcements. And Ricos are taking now the silicone roll and tries to bring it in the same thickness all around.
Okay. Is the pressure of how hard you roll over, is it important?
Normal pressure, like when you laminate a liquid resin.
Okay.
Yeah.
You only do it once, or?
No, we do it after 15 minutes, and then after 30 minutes, and after 45 minutes. So 3 times you have to do it. So give the resin a little bit time to get more liquid, massage, a little bit more liquid again, and then massage. So, and when these 45 minutes or 1 hour is done, let him close quick the oven. So he's massaging the resin a little bit.
Okay.
When the 1 hour is done, you can increase the temperature to 120 degrees Celsius.
Okay.
And then leave it there for 3 hours.
Okay.
After the 3 hours, switch it off, take it out, cut the socket in this case, grind it, and it's done.
Okay.
That's all.
Product finished.
Product is finished. Exactly.
Thank you very much. So.
Yeah. Now I'm coming to my presentation. I want to give you a summary of all the resin systems.
Thank you very much.
You're welcome. So we had different resin systems. First one was orthocrylic resin systems. Versatile, easy to mix, and proven since many years. Second one is the orthovinyl, vinyl ester resins. Easy of use and stable. And the third one are the Ottobock resin system, epoxy resins. Is structurally stable, but thin wallet is the device at the end when it's laminated. Let's have a look on the reinforcement materials. You see 1 dot at the acrylic resins. Why? You can use standard reinforcement materials, you can use the preforms that we have shown, but the bonding to the fibers is not the best. The only way to solve this challenge is that we are using a resin with a low viscosity, for example, a 8020 Pro. The orthovinyl resins has 2 points, so it's stable and has more or less a good bonding like the epoxy resins. But the best bonding to the fibers and the highest strengths have the Ottobock resin systems, that's why 3 dots. Third one is the mixing ratio. You remember the orthocryl resins are flexible, 100% hardener, 1, 2 or 3% of the hardening powder. The orthovinyl resin, 3 dots 2, flexible 2, the mixing ratio, 100% of the resin, and 1 or 2% of the hardener. And 1 dot for the Ottobock family, because there it should be exactly in the mixing ratio 126, so it's fixed. You have no chance to put plus minus, so you have no tolerance. That should be clear. the processing time in total from steering the resin until the product is finished, it's really quick. With acrylic resins, 45 minutes, 1 hour, so that's why 3 dots, 2 dots for the vinyl ester resins, 1 hour in the vacuum, 1 hour you have to temper, anneal it in the oven later, so that's why 2 dots, so it's a compromise between the acrylic and the vinyl ester, the epoxy resin. And the epoxy resin, 1 dot, because 10 hours in the vacuum and 10 hours later, plus another 1 hour at 60 degrees to get the final strength. It is important to do this process to get the good properties of the epoxy resin. Next one are the bonding of the fibers to the resin. 1 dot for the acrylic resins. Why? We have no bonding to the fibers. As I said at the beginning, the reinforcement materials which you can combine with the resin, you can just solve this problem with a lower viscosity resin like the 8020 Pro. 2 dots for the ortho vinyl ester resin, because it's stable and has nearly the same strength like the epoxy resin, but the best strength and the absolutely best bonding to the fibers has the epoxy resin, because we have also especially fibers for the epoxy resin. And the strength at the end, acrylic resin has no strength, it's just done by the reinforcement. The ortho vinyl ester resin has a good strength, but the highest strength, so with the thin wallet device, you can get just with the epoxy resins. I hope it's a little bit clear now, and it makes it easier for you to decision which resin is the best for my situation that I have at the moment. I will go over to the workshop.
Thank you very much, Tino. Thank you very much, Drikos. It was really interesting, and I hope you liked it as well. For further information, come and visit our website pem.ottobock.com. So thank you very much for watching. Stay healthy and all the best. Thank you. Bye-bye.
Bye.